press the bell icon on the YouTube app and never miss another update.
Today I am here to discuss about one more important concept in our mathematics, that is about sequences and series. Sequence, I think the concept of sequence is well known for you people, because this comes in the 10th standard, but here we are going to discuss about a special sequence, that is what AP sequence and GP sequence. Along with this we are going to discuss some special series. Okay. Now let us look at the definition of sequence. So what do you mean by sequence? What do you call as a sequence? Okay. So sequence, I mean sequence is nothing but an ordered arrangement of numbers. In other words, if numbers are arranged according to some definite rule, or if numbers are arranged according to some specific order. Okay, so an ordered arrangement of numbers, or yes, arrangement of numbers. Sequence is defined as arrangement of numbers. Arrangement of numbers according to a definite rule. A definite rule or order. Or we also defined as ordered arrangement of numbers. If you arrange some numbers according to some rule, for example, I am going to write some numbers 2, 4, 6, 8, 10 and so on. Okay. So this is an example for a sequence, and one more example 2, 4, 8, 16, 32 and so on, 1024. Okay, one more example, yes, 1 by 2, 2 by 3, 3 by 4, 4 by 5 and so on. So observe students here the pattern of these sequences, I mean these arrangements. Here first you look at the first arrangement. Here we have, in the first arrangement the difference between the consecutive terms is same, that is what 2, right. So I mean I can call this one as a sequence of even numbers, right, sequence of even numbers. I mean here the numbers are arranged in some definite order, right. Here also the numbers are arranged according to some definite rule. The rule is what? This is 2 power of 1, this is 2 power of 2, 2 power of 3, 2 power of 4, 2 power of 5 and so on, right. And here also we have some order. We have, these here the numbers are arranged or according to some definite rule. That is what? Observe here, observe the numerators. So natural numbers, denominators starts with the 2, 3, 4, 5. So this can be, yes, this is also, here also the numbers are arranged according to some definite rule. Then what rule we have used here? To find that, what we are going to do? We are going to find the nth term of this sequence. What do you mean by nth term? See, here the numbers in a sequence are called as the terms of the sequence, right? The numbers in a sequence, in a given sequence, are called as the terms of the sequence. And in this example, 2 is called the first term and it is denoted by A1. A1. This subscript represents the position. You mean A1 means first term, A2 means second term, A3 means third term, A4 is fourth and so on, and AN you mean nth term. It may be any term of the given sequence. For example, in this case, the nth term is given by, I am going to write this one as AN is equal to 2n, where n is a natural number. When n is 1, becomes first term, that is 2 into 1, that becomes first term. When n is 2, so A1 is 2, 2 into 1, so A2 is 2 to the 4, A3 is 2 3 6 and so on. Okay. So this is what we call as nth term. By knowing this nth term, you can find any term, any term of the sequence. For example, if I want to find the 10th term, yes, then you can find 10th term by using this. A10 is equal to 2 into 10, that is what 20. In the same way, you can find 20th term in the same way you can find the 30th term or 100th term and so on. I mean, that is the use of the nth term. In the same way, come to the second sequence. Here we have nth term is given by nth term is 2 power of n, right? 2 power of n, because 2 power 1 gives first term, 2 power of 2 gives second term. You mean a1 is 2, a2 is 4, a3 is 8, 2 cube. 2 cube is 8, you mean 2 into 2 into 2, you mean 2 multiplied 3 times, you get 8, 2 power of 4, 2 multiplied 4 times, you get 16 and so on. And in this case, yes, observe the pattern here we have. So this can be written as, nth term of this sequence can be written as n divided by n plus 1. Observe the pattern here. If you take it as n, this becomes 1 plus 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1 and so on. So this is what nth term of the sequence. By using this, you can find any term, for example 20th term or 50th term and so on. Hope you got the statements. This is about sequence of numbers. So this is we call as sequence of even numbers. In the same way we have sequence of odd numbers. Sequence of odd numbers is given by 1, 3, 5, 7 and so on. And the nth term of this is given by an is equal to 2n minus 1. This is about sequence. So what is sequence? Sequence is nothing but it is arrangement of numbers. It is nothing but arrangement of numbers according to some definite rule. That's it. Or ordered arrangement of numbers we call as a sequence. Sequence. Okay. Now, in some cases, for example, I am going to write a sequence of primes. Sequence of primes. So, yes, this is what sequence of primes. But here we don't know to find. We don't have any formula to find the nth term of the sequence, right? See, there is no formula to find the nth term of the sequence. But in this case, what to do? So this can be described only by the verbal description. Sequence of primes. That's it. There is no formula to find nth term. In some cases, we should not expect the formula to find the nth term. Okay. So we have some other examples like 1, 2, 3, 5, 8 and so on. This is also a sequence, but here there is no visual pattern. But this is a sequence we call as Fibonacci sequence. It is an example for Fibonacci sequence. Fibonacci. Fibonacci sequence is defined as, in this case, what? First and second term are equal to the same, that is 1. And third term can be got by adding the previous two terms, A1 plus A2. Yes. In the same way, A4 can be got by adding previous two terms, that is A2 plus A3. In the same way, A5 can be got by adding A3 plus A4 and so on. So, in general, the relation between the numbers can be written as an is equal to an minus 1 plus an minus 2, where n is greater than 2. So, this is what the definition of the Fibonacci sequence. A sequence in which a1 equal to a2 equal to 1 and an is equal to an minus 1 plus an minus 2 for all n greater than 2, and this is an example for, and this is what Fibonacci sequence. Hope you got, students. In some cases, should not expect a formula to find the nth term. So we define those. In such cases, sequences are described using using verbal description, right? So these are the two examples for that. Okay, now here we have examples for sequences. Sequence is nothing but what? Arrangement of numbers according to some definite rule, or arrangement of numbers according to some definite order, that's it, or specific order. Arrangement of numbers according to some specific order. Now, yes, this is the first term denoted by A1, second term denoted by A2, A3, A4 and so on. An is nth term, that's what. Nth term gives any term of the sequence. Okay. Now, so here we define a sequence as in two ways, so that is what? Finite sequence and infinite sequence. finite sequence and infinite sequence. So, the name itself says finite in the sense what? If a sequence has a finite number of terms, for example, in this case, in the second example, yes, here the last term is 2024. I mean, we have countable number of terms, right? We can count the number of terms in this. So, this is an example for finite terms, finite sequence. If a sequence is not a finite sequence, then it is called as infinite sequence. For example, first one, third one, and so on, and those two are examples for infinite sequence. A sequence which is not finite, we call as infinite sequence. Next, we talk about what the length of the sequence. The length of the sequence is nothing but the number of terms in the given sequence. That's it. The length of the sequence is same as the number of terms in the given sequence. Okay. Now, this is about sequence. Yes, hope you got it. Sequence is nothing but what? Arrangement of numbers according to, mathematically, we can define a sequence like this, arrangement of numbers according to some specific order, right? This is about sequence. Yes. Yes, we talked about a finite and infinite sequence, right? Finite sequence is a sequence in which we have finite number of elements, and infinite sequence is a sequence in which we have infinite number of elements. And also we talked about the Fibonacci sequence, an important one. Okay, so now let's look at what is actually series, right? What do you mean by series? Yes, we have discussed about sequence. Sequence is nothing but ordered arrangement of numbers or arrangement of numbers according to some specific order, right? So, what is a series? Here we have a sequence, right? A1, A2, A3 and so on. So, if I write 3 dots, it implies it continues, right? And so on, that is what AN. Here we have a sequence. Then series is nothing but sum of all the terms of the given sequence. Sum, yes, sum of all the terms of the given sequence we call a series of the corresponding sequence. I mean, series of n terms is denoted by Sn. Sn is equal to A1 plus A2 plus A3 and so on An. This is what the series of the corresponding this sequence, right? Okay, series is nothing but sum of all the terms of the given sequence. For example, here we have a sequence, and series is nothing but sum of all the terms. That is what is given by Sn. That's it. Okay, and we denote this by using a symbol. I mean, we call it as sigma. So Sn is also equal to. I mean, sum of all the terms is also. It can also be written as summation k is equal to 1 to n ak. This gives sum of all the terms from n is equal to 1 to k. For example, 1 to n. For example, here when k is 1, it becomes a1 plus when k is 2, plus in the sense, I mean this symbol denotes what? Adding, I mean summation of the terms from k is equal to 1 to n. Summation of the terms ak from k is equal to 1 to n. So, k is 1, you will get a1. When k is 2, you will get a2. When k is 3, a3 and so on. The last term is when k is n, you get an. This is same as sum of all the terms from 1 to n. I mean sum of all the terms of ak from k is equal to 1 to n. This gives, I mean this is what, this denotes what? Summation of the terms. Yes. So, this is about what? About sequence and series. Yes, sequence in the sense what? Sequence is nothing but it is an ordered arrangement of numbers, and series is nothing but what? Sum of all the terms of the given sequence. Okay. Now, let me move. Exercise, I mean Yes, first one 9.1 related to the sequence and series. Here, write the first 5 terms of each of the sequences given below, whose nth terms are given, right? Write the first 5 terms. Write the first 5 terms of the following sequences. Of the following sequences whose nth terms are. First one, an is equal to n into n plus 2. Okay, students, here we have nth term of some sequence. Yes, hope you know. Hope you learnt about the use of significance of the nth term. The nth term gives any term of the given sequence, right? It gives any term. If in place of n, if you take 1, it gives the first term. In place of n is equal to 2, it gives the second term. If n is 3, it gives third term, and so on, right? So now by using this nth term of the sequence, you can find the first 5 terms as when n is 1. So you get a1. a1 is equal to what? In place of n, substitute just substitute n is equal to 1. In place of n, 1 into 1 plus 2, that is 3. The first term is 3 of the sequence. Next, a2, when n is 2, 2 into 2 plus 2, that is what? 8. And a3, so you get 3 into 3 plus 2. In place of n, just substitute 3. So 5 is 15. In place of n, a4, fourth term is what? 4 into 4 plus 2. That is equal to 24. And a5 is 5 into 5 plus 2. That is what? 35. So the first 5 terms of the sequence are like this: 3, 8, 15, 24 and 35. So these are the first 5 terms of the sequence. First 5 terms of sequence. See, observe here. This is here the numbers are arranged according to some definite rule, and the rule is this one. N into n plus 2. N into n plus 2. Okay. Now the second one. An is equal to n by n plus 1. We have just discussed this. N by n plus 1, where n is a natural number. So when n is 1, gives the first term, a1 is equal to 1 by 1 plus 1, that is 1 by 2. When n is 2, so a2 is given by 1 by 2 plus 1, sorry, it's 2 by 2 plus 1, that is what? 2 by 3. Even in place of n, substitute 2 here. When n is 3, so a3 you will get 3 by 3 plus 1, you get 3 by 4. And when n is 4, you get 4 by 4 plus 1 is equal to 4 by 5. And n is 5, you get 5 by 5 plus 1, that is 5 by 6. So these are the first 5 terms of the sequence whose nth term is n by n plus 1. So the first 5 terms are given by 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6. Okay, this is your sequence. These are the first 5 terms of the sequence whose nth term is n is equal to n by n plus 1. In the same way, let me move a third one. Third one is like this. An is 2 power of n, right? So an is nth term is 2 power of n. So we need to find a sequence. You need to find the first 5 terms of the sequence whose nth term is 2 power of n. Yes, when n is 1, So 2 power of 1, that is 2. When n is 2, 2 power of 2, that is 4. When n is 3, 2 power of 3, that is 8. When n is 4, 2 power of 4, that is 16. You mean 2 is multiplied 4 times itself. So A5, that is 2 power of 5. So that is 32. 2 power of 4 in the sense 2 into 2 into 2 into 2. 2 power of 3 means 2 into 2 into 2. 2 power of 5 means 2 multiplied 5 times. 2 into 2 into 2 into 2 into 2. So that is what? 32. So your first 5 terms of the sequence are given by 2, 4, 8, 16, 32, so on. Student, this is important for, this concept is important for the purpose of annual examination because there is a 4 mark question, there will be a question for 4 mark, compulsory question in the annual examination, and there will be 2 3 mark questions, and there will be 1 mark question. Okay, so this is important for the purpose of examinations. Okay, now let's move on to the question number 4th. So an is 2n minus 3 by 6. 2n minus 3 by 6. So when n is 1, so a1 is 2 into 1, 2 into 1 minus 3 by 6 gives what? 2 minus 3 minus 1 by 6. So when n is 2, the second term is a2 is equal to, in place of n substitute 2, minus 3 by 6. So 2 to the 4 minus 3 is 1 by 6. And when n is 3, you get a third term, that is a3 is equal to 2 into 3 minus 3 by 6. You get 2 3 is 6. 6 minus 3, that is right, and n is 4. When n is 4, you get a4 is equal to 2 into 4 minus 3 by 6. So 8 minus 3, 5 by 6. When n is 5, you get to the fifth term, that is 2 into 5 minus 3 by 6. 2 5 is a 10 minus 3, 7 by 6. So your required sequence is minus 1 by 6, 1 by 6, 3 by 6, 5 by 6, 7 by 6, and so on. Okay, this is what a sequence whose nth term is 2n minus 3 by 6. Okay, now let me discuss one more. Fifth one, an is minus 1 power of n minus 1 into 5 power of n plus 1. Minus 1 power of n minus 1 into 5 power of n plus 1. Okay, now, so when n is 1, you get the first term, that is a1 is equal to minus 1 power of, in place of n substitute 1, 1 minus 1 into 5 power of 1 plus 1. So you get minus 1 power of 0, that is what, 1 into 5 square, so you get 25. So 25 is the first term of the sequence. Next a2, in place of n you substitute 2 minus 1 whole power of 2 minus 1 into 5 power of 2 plus 1. You get what? Minus 1 power of 1, that is minus 1 into 5 cube, 125. So minus 125 is the second term of the sequence. So a3 minus 1 power of 3 minus 1 into 5 power of 3 plus 1. Okay. Now this is what? Minus 1 power of 2. You mean plus 1 into 5 power of 4. 5 power of 4 is 625, right? Right? 5 power of 4 is 625. Yes, 125 5s are. You mean 5 power 4 in the sense 5 is multiplied 4 times, 5 into 5 into 5 into 5. 5 5 is 25, 25 5 is 125, 125 5 is 625. Okay. Now this is the fourth term, and the fifth is a third term. Fifth term is given by, sorry, fourth term is given by when n is 4, a4 is given by, yes, minus 1 whole power of 4 minus 1 into 5 power of 4 plus 1 gives minus 1 power of 3, that is what, minus 1 into 5 power of 5. What is 5 power of 5? So 5 power of 5 is what? 625 into 5. In 5 is multiplied 5 times. So 3125. So minus 3125 is the fourth term of the sequence. And A5 is given by, fifth term is minus 1 power of 5 minus 1 into 5 power of 5 plus 1. So minus 1 power of 4, you get plus 1 into 5 power of 6. 5 power of 6, so 3125 into 5. So 3125 into 5, right? So 15625. So this is the fifth term of the sequence. Hence, your sequence is given by a sequence whose nth term is minus 1 power of n minus 1 into 5 power of n plus 1 is given by the first term is 25, second term is minus 125, third term is 625, and the fourth is minus 3125, and the fifth term is 15,625, and so on. Okay. So this is our required sequence whose nth term is minus 1 power of n minus 1 into 5 power of n plus 1. Okay, let me move. Fifth question. An is nth term of the sequence is n into n square plus 5 by 4. Okay. We have to find a sequence in which nth term is n into n square plus 5 by 5. So a1, in place of n you substitute 1, 1 into 1 square plus 5 by 4, you get what? 6 by 4, right? A2 is 2 into 2 square plus 5 by 4. So you get 2 into 2 square plus 5. So 2 square plus 5, 9 by 4. 18 by 4, or you can write here 3 by 2. Here you can write 9 by 2. Okay. Right. Now A3 is what? 3 into 3 square. 3 square plus a 5 by 4. So we get 3 square, 9 plus 5. 3 square is 9 plus 5, 14, 3 into 14 by 4, right. So 21 by 2. This is our third term, and the fourth term is A4 is 4 into 4 square plus 5 by 2, sorry 4. You get 4 into, I can cancel this, 16 plus 5, that is what, 21. Next, your fifth term is 5 into 5 square plus 5 by 4. You get what? 5 square is 25, 25 plus 5, 30. So 30 into 5. 150 by 4, or you can write so 2 2s are 5s are. So your sequence is given by 3 by 2, 9 by 2, 21 by 2, 21, right, and 75 by 2, and so on. Okay, this is how finding sequence whose nth term is given, right. So this is the first main of first exercise 9.1. Now let me move the second main. Second main is like this. Find the indicated terms in each of the following sequences whose nth terms are. Find the indicated terms in the following sequences whose nth terms are. In this case, nth term will be given, and the terms to be found will be indicated. Like first one is nth term is what, 4n minus 3. You to find A17, you mean 17th term, and A24. Indicated terms are what? 17th and 24th term. Simple as before. 17th term, you mean A17 is 4 into 17 minus 3. I mean, in place of n, I just substituted 17. Okay, 4 17. Yes, 4 into 17 minus 3. In place of n, I just substituted 17. So you get 68 minus 3, that is what, 65. Next, 17th term is 65, and 24th term is A24 is yes, 4 into 24 minus 3. So you get so 96 minus 3, that is what, 93. So 65 is the 17th term, 93 is the 24th term. Okay, second one. N is n square by 2 power of n. N square by 2 power of n. So indicated term is A7. You have to find 7th term of the sequence. 7th term of the sequence whose nth term is an is equal to n square by 2 power of n. Now A7 is equal to, in place of n you have to substitute 7. 7 square divided by 2 power of 7. 7 square is 49. divided by 2 power of 7. So, you have to multiply 2 7 times. So, 2 2s are 4, 4 2s are 8, 8 2s are 16, 32, 64, 64 2s are 128. So, 49 by 128 is your the 7th term of the sequence. Next one. N is minus 1 power of n minus 1 into minus 1 power of n minus 1 into n cube. You have to find a9, 9th term of the sequence. So, a9 is, this is what the nth term, do not confuse students. In these cases, this is what the nth terms and this is what the indicated term you have to find. Now, a9 is in place of n, substitute n 9, so minus 1 power of 9 minus 1 into 9 cube. So, you get minus 1 power of 8, that is plus 1 into 9 cube. So, 1 into 9 cube is 9 into 9 into 9, right, 9 into 9 into 9. So, you get what, 9 9s are 81, 81 9s are 721. Okay. So, 721 is your, sorry, 729 is the 9th term of the sequence. Next one. Okay, this is how finding the indicated terms whose nth term is given. Now, let me move a third main. Third main is like this. Write the first 5 terms of each of the following sequences and obtain the corresponding series. Right? Write the first 5 terms of the following sequences. And obtain the corresponding series. Okay. So, you write first 5 terms of the sequence whose nth term is given and also the corresponding series. The first one is A1 is given, that is 3, nth term is 3 into a n minus 1 plus 2 for all n greater than 1. Okay. Now, first term has been given. Okay. Now, a2 let me find. A2 equal to 3 into a2 minus 1 place of n substitute 2 here plus 2. You get what? 3 into a2 minus 1 is a1. So, 3a1 plus 2. a1 is what? 3 we have. So, 3 into 3 plus 2. So, 3 3 is a 9 plus 2. So, 11 is the second term. Now, third term is a3 is equal to 3 into a 3 minus 1, in place of n substitute 3 plus 2, you get what? 3 into a 3 minus 1, that is what? A2 plus 2. So a2 we have 11, 3 into 11 plus 2. So 33 plus 2, 35. This is your third term. And a4 is what? 3 into a4 minus 1 plus 2. So 3 into, what is the a4 minus, that is what? A3 plus 2. 3 into a3 is what? A3 is, we have 35 plus 2. So 35 2s are, 35 3s are, so 105 plus 2, that is 107. And a5 is equal to 3 into a5 minus 1 plus 2, that is equal to 3 into a5, mean a4 plus 2. So 3 into a4 we have, that is 107 plus 2. So 3 into 107, that is, so 321 plus 2, that is 323. Okay. So these are the first 5 terms, that is what? First term is 3, second term is 11, 35, 107, 323, or the first 5 terms of the sequence whose nth term is what? 3 into a n minus 1 plus 2. Hence the corresponding series is given by first term, that is 3 plus 11 plus 35 plus 107 plus 323 and so on. This is your corresponding series. Okay. Second one, I mean in the exercise 13th problem, a1 is given, a2 is given, that is both are equal to 2, and nth term is an minus 1 for all n greater than 2. Here first 2 terms has been given, both are equal to 2. Now let me find third, fourth and fifth terms. Now third term, that is what? a3 is equal to, an is a3 minus 1 that is equal to a3 minus 1, that is a2 minus 1. a2 is what is given, that is 2 minus 1, that is what? 1. So your third term is 1 and fourth term is a4 minus 1 that is equal to 4 minus 1 is 3, a3 minus 1. So a3 is what? We have 1. So 1 minus 1, that is 0. 0 is the fourth term of the sequence. And a5 is equal to a5 minus 1, that is a5 minus 1 is a4 minus 1. a4 is what? We have 0. 0 minus 1, that is what? Minus 1. So the first 5 terms are 2, 2, 1, 0, minus 1. Corresponding series is given by. So 2 plus 2, first 2 terms, 1 plus 0 plus 1 or plus of minus 1 and so on. Okay, this is your corresponding series whose nth term is an minus 1 minus 1. Okay. Okay, students, this is about the first part of the chapter, sequence and series. So now I will continue this in the next session. Okay, thank you.